All right then, shall we begin? Good morning, everyone. How are you doing? Ashley seems raring and ready to go, already asking questions. Fantastic. So before we jump into today's stuff, let's review yesterday's, because today's actually the distance formula is secretly the Pythagorean theorem the whole time. That's okay. I've spoiled it already. Gosh darn it. That's okay. All right. As I said, let's review Pythagorean theorem real quick. So here are my answers on screen. Go ahead and take yours out. Check how you did. Ask away. 1, 2, and 3, very straightforward. 4, a little bit sneaky. You have to undo the area formula first to find that other leg of the triangle. And then you have 2 out of the 3 sides, and you can Pythagorean theorem for the third side. Number 6, sure. All right, so first step, number 6, find the coordinates of point C. That's this guy right here. Well, you can see that it lines up with point A and point B. So if it's the same horizontal space as A, I need the same y value, right? Because that doesn't change when I move horizontally. So I'm going to copy the y value from A, -1, and then vertically lines up with B, so the x value, how much it is left and right, didn't change. So I'm going to steal the x value from B, that there. That's my coordinates for C. And now I need to find the radius of the circle, which is from A to B right there, which is the hypotenuse of this triangle. Fancy that. This is actually going to be a perfect example of what we'll do on our worksheet today. Because I'm going to take these coordinates and use them to determine the length of the legs of my triangle. A has an x-coordinate of 7, C has an x-coordinate of 11. So from 7 to 11 is how much? That's right, 4. And same thing from C to B, except y-coordinates, because it's moving up and down. From -1 to -4 is how much? That's right, 3. Look at that. It's a 3, 4, 5 triangle. Pretty nifty, huh? All right, there's let me get them both on screen. 7 and 8. A little bit of subtraction, get the triangle transfer, and then you can find this height from Pythagorean theorem on this triangle, and then multiply for the area. 8, this is 3, so Pythagorean theorem to get that, which is the same as this. Add it back to the 3, now you have this side and this side. Pythagorean theorem to get that, which is the same as it. Repeat, repeat until you get RV. Nine is a little funky. I like these kinds of questions, the what's wrong with this picture scenario, because this is something, a skill you need to develop for yourself, just to check your own work, right? Well, if you're calculating along and you get something, you should be able to look at it and say, wait a minute, that doesn't make sense. If I have this kind of area, what I know about a circle, there's the radius, pi r squared, so square root of 16, it should be 4. That means this little bit is 4, but this whole thing is 3. The hypotenuse of this triangle can't be less than the leg of the triangle. That doesn't work. And number 10, also a good thought provoker here. Start by drawing the picture. If you did not set up this, this picture here and you had trouble, I can't help you there. It's like, you've got to draw the figure. Okay? And ultimately, they want you to find the area. Well, it's a right triangle, and I have 2 legs perpendicular to each other. Great. Multiply. Take half that. There's the area. Find the hypotenuse. Got 2 legs. Pythagorean theorem to get the hypotenuse. Straightforward so far. The tricky bit is the altitude to the hypotenuse. We didn't cover altitudes. It's one of those special lines you can draw inside of something. And an altitude is just this. It's a straight line from one vertex to the opposite side, and it meets it perpendicularly. So in fact, the legs of a right triangle are altitudes to their opposite side. This line is perpendicular to the opposite side, but there's nothing perpendicular to the hypotenuse unless I draw it in down the middle. And they want to find what's that height. And the secret to discovering that is with the area. You already calculated the area. The area of the triangle is constant. It doesn't change just because you calculated it differently. Any base times perpendicular height divided by 2 gives you the area of the triangle. So you know this length, you know the area, you can divide to solve for this height. This height of the altitude times this hypotenuse length is a base times height. Take half that would give you the area. So you can work backwards to determine what that must have been. Sneaky, sneaky, huh? All right, any remaining questions on yesterday's Pythagorean theorem exercises? No? All right, then Ashley, I'm going to tease you a little bit more by delaying today's work yet again. We're going to jump to the quizzes for today. Right? I'm going to do that first because honestly, today's work is really pretty short. My bit to share with you, real quick. Right? I can finish it in like 2 sentences and we'll do an example together and then you'll be set. So before that, let's run a quizzes here, practicing Pythagorean theorem, because as I hinted before, you're going to need this mastered for distance formula the rest of today. So let's start one up here. It's going to go classic mode. Yes, there's 19 questions. They are fairly short. There's several true, false, or pick between 2 answer type questions. So it's not actually that long. Go ahead, go to joinmyquiz.com. Enter the game code 273050. Once again, joinmyquiz.com, code 273050. All right, we've got 7 in, almost there. Eight. Who am I missing? Nine. All right, let's begin. Like that, I'm going to sit here by my toasty little fire. Ooh, hey, don't go that fast. We've got time, we've got time. Think about it for a couple seconds. Remember, you can use your notes, pencil and scratch paper, jot a couple things down, check for Pythagorean triples, open up a calculator if necessary. Oh, 59%, 60, things are looking up. All right, 70%, keep climbing. Oh, streaks are going into the purple now. Fantastic. $73, keep it up. Ooh, 75, pretty good. Let's see, about wrapping it up in the next 2 minutes. Then we'll go on to today's new material. All right, Gisela, feel free to keep working. I'm going to go on. If you just listen in the background, you can finish the rest of your questions. But let's take a look at one major application of the Pythagorean theorem, and that is the distance formula. You may have heard of this fancy thing before. It looks kind of complicated, but I assure you it is not. If you take the Pythagorean theorem and you add in coordinates, as in you deal with the coordinate plane, what you end up with is the distance formula. That's all it is. It's Pythagorean theorem applied to x and y coordinates. So here it is. If you don't have this written down on your page somewhere, go ahead and copy that guy right at the top of your worksheet. That is the distance formula. D for distance, right, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Why did I say this is the Pythagorean theorem? Because all we're doing is we are finding the sides of our triangle, right? x2 minus x1, you're just taking the difference of those coordinates to find out how long is that horizontal leg. The difference between these coordinates gives us how tall is that vertical leg. And then square the two, add them, and you'll get c squared, but we don't want c squared, we want just c, so we square root the whole thing, right? Except now we replaced c with d because we call it distance. But it's just Pythagorean theorem. In fact, I have never used the distance formula myself. I don't think of it that way. You write this thing down and then forget about it. You can just cross that off because you don't need it. Just think in terms of the Pythagorean theorem. Turn everything, where possible, into a triangle. Okay, you don't actually have to cross it off. But so take a look at number 1 here on our worksheet. Find the distance between each pair of points. They've drawn it in for us. Very lovely there for you. Visual people, you might want to create this sketch where they don't give it to you. And so the first thing I would do is I would turn this into a triangle. Exactly like you would do if you were trying to find the slope of a line, right? You're drawing a little triangle and you get your rise over run, except we're going to do something different. But we're finding those very same values. Okay, so this goes from here to there. I don't care what the numbers are. I just need to count, right? 1, 2, 3, 4, 5, 6, 7. It's a distance of 7. Yes, it was because this is up here at 5, and this is down here at -2, and 5 minus -2 equals 7. You can do that. And when you get to these guys where they only give you the coordinates, that's what you're going to have to do, right? Or draw it out yourself from scratch. But I would start up here, just get in the habit of creating that triangle, because this is guaranteed a right triangle when you draw the X and Y lines there. And then we count this guy from here to there. 1, 2, 3, 4, 5, 6. I count 6. How do I know that? Well, because this is -5, and this is 1, and -5 minus 1. Well, that's -6. Can we have a negative distance? Well, okay. Does it really matter which way you go? -6 squared is the same as 6 squared, which is how you have to calculate it anyways, right? So don't worry if one of them ends up negative. Does not matter in the slightest. Right? With slope, it totally mattered. You had to make sure you matched the order on things so you lined up so you would make sure the signs came out right. But we're going to square these numbers. Don't fret about that. All right, 7 and 6, that's not on my list of triples. So I got to go the long way and actually square these. So 7 squared is 49. 6 squared is 36. 49 plus 36 equals 4, 5, 6, 7 plus 15. 85. And then we need the square root of that. Pretty good? That's the answer. That's the distance. How much is this length? Square root of 85. Right? Plug that in your calculator. Get your approximation there. About 9.220. All right. Ashley, does that help? Since you're the one that asked about this question specifically. Yes? Good. All right. Does anyone have any other questions on how to deal with the rest of this sheet? Okay, then let me say a little bit more on these ones here where they only give you the coordinates. You're matching them up. So I would look at it like this. Grab the x, and the y, and the y, and just pair them up like that from negative and subtract them. All right, so -2 minus -7 minus negative, same as plus. So -2 plus 7 would be 5. I've got to, draw the line. There we go. And then 3 minus -7. Once again, I'm adding that, so that'll be 3 plus 7. That equals 10. Okay, so now I have my two sides. Think of those as the two sides of your triangle. I would work it like that. Two-step process. First, find the two legs of your triangle, then Pythagorean theorem to find the hypotenuse. To me, that seems easier than trying to remember this ginormous formula, right? It's much bigger and more complicated looking. Yes, you've got it written down on your page. You can refer back to it. Right? So if you like using that, go for it. Just line everything up, plug it in, and it's away. Totally up to you. Now, of course, we're only required to do the odd-numbered exercises on this worksheet. There is 2 pages worth of material here, odds only, on the whole thing. So you can just ignore this whole column down there. All right? Final questions. No? Okay. Retake code will be posted at the end of the day at 2:30. You have the remaining 12 or so minutes to work. I'll leave you to it.